Hello everyone, welcome back to this online class. Today we are going to look at a problem in economics. We want to see how to apply the concept of differentiation in solving economics problems. And in particular, I want us to answer this question. We are told that a monopolist faces the demand function P is equals to 200 minus X. The total cost function is given by C of X is equals to 100 minus 40X plus 5X squared. Now we are asked in part A to write down the monopolist's profit as a function of the quantity produced X. In part B, we are asked to find the maximum profit, the profit maximizing level of production, and the price per unit that will give us maximum profit. And in part C, we are asked to find the revenue when the cost is minimized. And lastly, in part D, you are asked that how does the profit maximizing level of production change if the government imposes a lump sum tax, L dollars, per each unit sold. So let's answer part A. We write a solution. Remember, for you to get profit function, you must first of all be able to find the revenue function. So based on what you have been given in part A, we know that revenue, which is R of X, is simply equal to X times P of X, where X is the quantity produced and sold, and P of X is the demand function or the price per unit. So when you multiply, we'll have X times, our P of X is the same as 200 minus X. And so you open the bracket, that will give you 200X minus X squared. That is our revenue. So our profit is simply revenue minus the cost. Revenue, of course, let me write P of X to mean profit as a function of X. If I write revenue minus cost. So profit, we are going to write this as P capital, a function of X. That is revenue minus the cost. Our revenue is 200X minus X squared. This one is subtract the cost which we are given as 100 minus 40X plus 5X squared. So when you subtract, you're going to get 200X minus X squared minus 100 plus 40X minus 5X squared. And so combine the like terms. This will give us, let's start with the negative 100, or simply negative 100 plus 240X minus 6X squared. That is our profit function. Now that we have answered part A, now we need to answer part B. In part B, we need to find the profit maximizing level of production. We also need to find the maximum profit and the price per unit that will yield maximum profit. So let's answer that one. Right here, part B. Now, you know, at maximum, at optimal profit, at any maximum or minimum, we know that derivative of the profit function with respect to X must always be equal to 0. So let's differentiate profit with respect to X. So you can say now dP with respect to X, that will give us 240 minus 12 X. 240 minus 12X. So when you equate to 0, what do we get? So this one equate to 0. So you can just say therefore 240 minus 12X is equals to 0. And so you can now find X from here. You can say from here X will be equal to 240 over 12, which is 20. And the X, there is the number of units that you produce and sell. So we can write this as 20 units. But I told you that we are not sure whether this value of X will give us the maximum profit. So for you to be sure, you must use the second derivative test. So I also need to find the second derivative of this profit function. So we'll write d squared p dx squared. Differentiate the first derivative, you get negative 12. Negative 12 is less than 0. So that value is less than 0. That means the value of X that you have found will give us the maximum profit. So you can just say since d squared p dx squared, the value is less than 0. Therefore, X is equals to 20 is the profit maximizing level of production. That for you to maximize the profit, then you must be able to produce and sell 20 units. You can now be able to advise the company, because every company aims at maximizing profit, maximizing revenue, while minimizing cost. So we also need to know the maximum profit. Maximum profit, I'll write with another color. Maximum profit, that is simply P of 20. When X is 20, what is the profit? So that is negative 100 plus 240 times X, which is 20, minus 6 times 20 squared. And so this will be equal to, I can write it in the next line. Let me get rid of that. So this is equals to, you can now press that in the calculator. We have negative 100. We are adding to 240 times 20. Then we are subtracting 6 times 20 squared. The result is 2300. So that's our maximum profit, $2,300. So that is the maximum profit. What else do we need to find? We need to find the price per unit that will yield maximum profit. So we also need to find price per unit. That will yield maximum profit. So that is the small p. The small p when X is 20. So that P small is equals to, remember, you are told the small p, which is the price, is equals to 200 minus X. So that would be 200 minus our X. In this case, we have found 20. 200 minus 20 is the same as 180. And so that is in dollars. So that means for you to get the maximum profit, then each unit must be sold at $180 price per unit. So we've answered part B. Let's go to part C. We are asked to find the revenue when the cost is minimized. Remember, when it comes to cost function, you minimize the cost, you don't maximize the cost. So I'll write here part C. In part C, we want to minimize the cost. So at optimal cost, you see, I'm using the word optimal because I'm not sure that the value of x that I'll find when I equate the first derivative of c with respect to x to 0 will give us the minimum cost, unless we show using the second derivative test. So at optimal cost, we know that derivative of c with respect to x must be equal to 0. So now, let's find dc dx. Look at our cost function. Our cost function was 100 minus 40x plus 5x squared. When you differentiate that with respect to x, you get negative 40 plus 10x. So now equate this to 0. This equation will now become, you can say therefore, negative 40 plus 10x is equals to 0, of which if you make x the subject, you're going to get x is equals to 40 over 10, which is 4 units. That means if you produce 4 units, you will be able to minimize the cost. So that is but we don't know whether truly that will be the cost minimizing level of production unless we test this using the second derivative test. So I'm going to get the second derivative of c, d squared c, with respect to x twice. That will give us 10. And you see 10 is greater than 0. That confirms that the value of x that we have found should be able to give us the minimum cost. So you can just say, therefore, you can say since d squared c dx squared is a value greater than 0, comma, therefore, x is equals to 4 units is the cost minimizing level of production. That is the cost minimizing level of production. Now, we are asked to find the revenue when the cost is minimized. So we can say hence the revenue when the cost is minimized is, that will give us R of 4. Look at our revenue function. We got 200x minus x squared. So that is 200 times 4 minus x squared. This is 4 squared. And so this is the same as, let's work it out. That is 200 times 4 minus 4 squared, which is 16. And so you need to get 784. So this will give us 784. And this is again in dollars. So that if you minimize the cost, then your revenue will be at $704. That is part C. Let's see the other part. Part D. What are we told? Remember, we have answered these 3 parts. Let me just tick. We have answered this, we have answered this, and also this. That's clear. Part D. How does the profit maximizing level of production change if the government imposes a lump sum tax L dollars per unit, per each unit sold. So in this case, now you have a tax that is being imposed on the goods that you're selling, producing and selling. You have to pay some tax to the government. How do we cater that in our solution? So in part D, this is how we begin. Of course, if the government imposes a lump sum tax of L dollars per each unit sold, the total tax bill will now be given by, so total tax bill is, I'm going to call it T capital to mean the tax. You see, every unit you're selling, the government is charging you L dollars. How many units have you sold? There are X units. This company, this monopolist, produced X units of the commodity and sold the X units. And you are told that every unit that you have sold, the government is going to charge you L dollars per each unit, so that the total tax that you owe the government will be equal to L times X, total tax bill, L times X. So what happens when you pay tax? It means that profit that you are getting even before you pay tax, it will reduce, because your tax is like a deduction. So that profit that you got will reduce by the amount that you have used to pay the government. So our new profit function, given the lump sum tax of L, is now given by, so we can just say the new profit function is, look at our original profit, it was P of X, is now the original profit which we got, let me go back, profit function. We got negative 100 plus 240x minus 6x squared. So that's what we write here. Negative 100 plus 240x minus 6x squared. Now, because we are paying tax, it is this minus the tax that we have paid, because the profit will now reduce since you have used some amount to pay the tax. And so this you can now write, because I know T is equals to Lx, this you can now write as negative 100 plus 240x minus 6x squared minus Lx. That is the tax. So again, because we need to know now, initially we got the profit maximizing level of production. And once you introduce tax in the equation, that profit maximizing level of production has to change. So again, we need to know what is the new profit maximizing level of production. So we we'll write at maximum. Let me use another color. At optimal profit, what we know is that dP dx must be equal to 0. So let's get dP dx. So we can say now dP dx is equals to 240 minus 12x minus L. Now, when you equate it to 0, what are we going to get? We are going to get 240 minus 12x minus L is equals to 0. And so from here, you can make x the subject. 12 of x is equals to 240 minus L, which simply means that x is 240, and that should be 240 minus L over 12, which you can write as 20 minus L over 12. This is the new profit maximizing level of production. So it is 20 minus L over 12. Of course, that will give you the maximum profit. If you differentiate again, we need to confirm whether this will give us the maximum profit. So this squared P dx squared, second derivative, that will give us negative 12. Negative 12, which is less than 0. So it is true that the value of x that you have found is the new profit maximizing level of production. So you can write since, let me start with since, then therefore will come later. You can write here since d squared P dx squared is a value that is less than 0, comma, therefore this value of x which you have found to be 20 minus L over 12 units is the new, that is the new profit. The new profit maximizing level of production. So we have confirmed that. Now the government raises a total tax bill of how much? Now that we know x to be 20 minus L over 12, so what is our total tax bill, which was L times x? So you can just say hence our total tax bill should now be equal to T is equals to, remember it was L times X. L times our X is 20 minus L over 12. And so this you can write as 20L minus L squared over 12. I'm now expressing T as a function of L. So remember, even the government needs to maximize the tax bill. They need to get, or simply get, the maximum tax as much as possible. So we need to maximize T. So you can write this that at maximum, let me use the word optimal because I'm not so sure whether what I'm going to get will give us the maximum tax. So at optimal tax bill, at optimal tax, we know that dt dl must be equal to 0. So let's differentiate. So we can just say now dt with respect to L is equals to 20 minus 2L over 12, which is L over 6. And so when you equate it to 0, what are we going to get? So we are going to get, you can just say therefore, 20 minus L over 6 is equals to 0, of which if you solve for L, you get L is equals to 20 times 6, that will give us 120. L is equals to 120. So, but we also need to know, this is in dollars. That is $20. Because we don't know whether this will give us maximum tax revenue or minimum tax revenue, we have to use the second derivative test. So I must find the second derivative of t, d squared t, with respect to L twice. Differentiate, of course, 20 is a constant, the derivative is 0. When you differentiate L over 6 negative, you'll get negative 1 over 6. So that's negative 1 over 6. A negative value that is less than 0. As long as it's less than 0, it means that value of L that you have found will give you the maximum tax revenue. So this simply means that you can say since d squared t with respect to L twice is a value less than 0, comma, therefore L, which we have found to be 120 units, is, or simply will maximize the government's tax revenue. So for the government to maximize the tax, then they have to charge you $120 per every unit that you have sold. So then the task is, what is the new profit maximizing level of production? So you can just say, therefore, the new profit maximizing level of production is, it was X is equals to 20 minus L over 12 minus L, and our L is, let me write L over 12. And so this will be 20 minus 120 over 12. This is the same as 20 minus 10. And so that is equals to 10. 10 units. So that means now when they start, you need to maximize your profit, then you have to sell each unit produce, or simply you must produce and sell 10 units. So we have answered all the questions in all the parts in that question. Thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, to like, and also to share this video. When we meet next time, we look at other problems in Calculus 1, especially in applications of differentiation techniques. Let's meet next time. Bye-bye.